be supporting you when you buy a kiln. I see some kiln owners on here, some people I may have talked to in the past. And, today we have a special guest. We have Brian. He's our head engineer. He started for VacuTherm when we were originally VacuTherm, and he was a huge part of the iDRY brand, what the iDRY kiln is, helping bring that idea to life and help out a lot of drying needs in the way. And just want to, if anybody has questions for Brian, or we can just chat about Brian, talk about the start of iDRY a little bit, and what was our goal, because VacuTherm's still great. It was just a very complicated system that you were involved with making. And
back in the day, vacuum drying was complicated and expensive, and certainly not for everyone. And it was a selected few people that got into it, and those that loved it. Those that hated it for different reasons. And Jim's dad started the company some 40 gazillion years ago, and it was Jim's dad retired, and Jim Parker, that everybody knows and loves with iDRY, got handed over the reins and got the company. And I was the other employee in the company. And he looked at me and said, "What are we gonna do? We gotta, I've got the company. We need to do something to make this simple and easy to use, and we got to break the old the old thinking." And so we just sat around for days and days and days and just whiteboarded and drew on napkins and talked about how could we make vacuum and just drying in these vacuum kilns easy and simple. And it was just a few of us in the beginning, so they had to last. They had to be bulletproof. They couldn't break down, because we couldn't afford to get a gazillion phone calls. And so we put on the list of things that we needed them to do: be easy, cost effective, anybody could buy them, simple, and then we just figured out how to make it happen.
Yeah, that's awesome. And talking with you and Jim and the old VacuTherm units, it was like you guys talked about having like a Ferrari motor on there. Everybody wanted to see what they could do with a vacuum kiln,
right,
trying to dry wood in 2 days, and a million BTU boiler, and that you were constantly.
We discovered that was half the problem. It's you're trying to drive a Ferrari with a 100 horsepower engine, and you only want to drive it 45 miles an hour on a dirt road. A Ferrari doesn't want to do that. You'd be shifting, and you'd be hitting the gas, and it'd be a bumpy ride. And then we looked at each other and said, "Well, why are we trying to drive a Ferrari? We should be driving a golf cart, for crying out loud. Maybe a pickup truck with a 2-stroke engine." And so it's really easy to engineer something and overbuild it. It's really hard to engineer something and meet the criteria that you're looking for, because there's so many unknowns, and it's math is complicated, but to truly engineer something that's right on point, and that's hard to do. So we had to figure out what the right size engine was. What we wanted to make something that was in balance with the speed of drying, our technique, what wood wants to do. That was a key moment when we discovered that we were just trying to drive the wood too hard, and we didn't need a million BTUs to do it. We only needed 80,000 BTUs. What a big difference. Yeah. And the cost ratios start to really change. When you're not trying to sell a Ferrari, you're trying to sell a go-kart almost.
Yeah. And
Um,
I mean,
so that things changed dramatically once we figured out we wanted to be in this balance, the same balance that the wood wanted to be in.
mhm. And we talk about the cost has changed. I know our kilns are still a little more expensive, but they used to be way, way, way more
Oh,
expensive
way,
when
way,
we were in
way,
that
yeah,
Ferrari situation. So
yeah. But today, I
costs
mean,
are
you during
substantially better.
yeah, well, but still, you do the return on investment, even though we're out of the box a little more expensive. But when you do the ROI, you got a year or two payback,
Yeah.
and that if you've got that kind of return on investment, boy, that's something.
Yeah, absolutely. And we talk. I've used that reference before, that the golf cart motor instead of the Ferrari motor. And just what we're talking about with that is the wood water kind of dictating the speed in which the kiln operates. We don't want to be able to overdrive the wet wood and bump up heat really quickly and have those case hardening issues. We want to have just enough heat so that the water slows down the temperature rise. And as the wood gets drier, your speed picks up with that curve, which is what Brian's talking about. And, it was a challenge kind of hitting that exactly on the mark, I'm guessing, from an
Yeah,
engineering standpoint. But
yeah.
um, yeah.
But
And
it was a fun challenge, and it was Jim's vision. He wanted to have these, and that was the rebranding. And so when it was this new vision of Jim and the new product, it was the rebranding of iDRY, and that's how we went to market with this new design, the new designs. And what we have now for product line was the vision of back then.
yeah,
Yeah.
that's awesome. And we'll open, if anybody has questions throughout this process, feel free to just put them in the chat. I believe we're using that instead of the Q&A on this one. But we like to keep this loose and just go with the flow, answer questions as they come in. If not, we'll just keep chatting
We'll keep
about the
chatting.
kilns. And
Yeah, and we have a lot of new products in the works. We're not just gonna sit back and relax. Jim and I are still writing stuff on the whiteboards and napkins, trying to think about what's additional product offering
yeah,
that we come up with, and different ways to do things.
yeah, absolutely. We're always trying to stay ahead of the curve
Yeah,
for us and our customers. So you guys have the best options available. And since I don't see any questions, I want to ask one that I get asked all the time: is why don't we monitor the wood with probe meters as it's drying? I know
yeah,
it's a question you've answered before, but
yeah. We get that a lot.
yep,
In fact, we used to do that all the time. In fact, we threw a lot of money at that kind of system. We had a wireless. I think it was from Lignamat, and it was sensors and receivers, and um, at the end of the day, every moisture meter is only just so good. They're sometimes they're good, and sometimes, well, I don't really know what that means. And if you're if and in an in kiln probe system, how many probes can you really put in there? So you're more often than not, you're relying on two or three probes and data points that may or may not represent everything that's everything that's there. And so you always have to take it with a little bit of a grain of salt. um, and then again, you're relying on one measuring method, and how you inserted the pins and where you put them. So there's so many factors that
yeah,
can be, it's kind of hit or miss. It's whether that's a good reading or not. I'm still a big fan of just poking around, and I use 4 different brand moisture meters. I don't rely just on one meter. I use 2 surface meters, 2 pin meters. And there's also nothing like tapping on the wood and hearing the noise it makes wetter or drier. There's touchy feely
Yeah.
things that you just, you get after a while, which are just fun, the knocking on wood. And, Jim will go, I think that's dry. And he just knocked on it with his hand. And it looks pretty dry to me. There's stuff that you get to see, and it's super easy to during a drain cycle, when the system is released vacuum, to open the door and poke around a little bit. Is
It
no
doesn't
harm, no
cost you any
foul. It doesn't.
time.
Yeah, but those who want to still do an in-kiln moisture meter, Delmhorst does have I think it's the in-kiln kiln troll or something.
Yeah.
If you already have their meter, I think the sensor and if you already have their meter, their cables and package, I think is just in the $500-800 range, and then their meter is another $500-600. So, I mean, if you already have their meter, you're halfway there. But so a few guys have used it. The challenge then is to pass those wires through the wall of the chamber, and there is a port for that. There's a spare port that's not being used that we can tell you about if you're so interested.
Yeah. All right, cool. So we got some questions rolling in. Brian, I'm gonna let you answer the first one, then I'll answer the next two. So the first one is from Daniel Avery. The time/moisture schedule you are talking about, do you have them for most species and thicknesses? So he's talking about schedules and things.
Yeah, we don't we really don't talk about specific schedules per se. We have a kind of a rule of thumb that we can dry in a certain amount of time per inch of thickness, right? And there's some species that take longer than others, and the medium density woods, the poplar, birch, ash, maple, a lot of the 90% of the stuff we talk about dries about 1 week per inch of thickness, and with a lot of caveats. I mean, there's drying is not perfect. That sometimes the same load will take you 7 days to dry. Some next time you do the exact same stuff, it'll take 9 days to dry. So there's a lot of variables, but there are some species that we know are going to take longer, and those are the walnuts, the white oak, even red oak. You have to be a little slow in the beginning, so red oak will go easy on the red oak, but white oak takes forever. I mean, we do a great job with walnut, but sometimes you gotta wait for it, and it's painful. But a walnut may take twice the week per inch of thickness, so it might take 2 weeks per inch of thickness. And there's a lot of different variations in walnut, so there's a lot that can depend on that. But but those are the couple that are the bigger differences: the walnut and the white. Oh, then there's always the softer woods, which you would think you'd dry faster, like a pine or a cedar. But the challenge for us is that water comes out so fast. It's getting that water out of the box, and then we have to kind of play games with doing more drain cycles to get the water out. And at the end of the day, we're still a week per inch of thickness with a pine or a cedar, just because we're trying to get that so much. There's so much water that we're handling that it's just a little different.
Yeah, and as far as the schedules, there's only so many things you can adjust with a vacuum kiln. There's time in the kiln, temperature, and your drain cycles, really. So we kind of try to put the wood in an environment where it gives up moisture as quick as it can. Like Brian said, some take longer than others, but there's not really schedules per se.
Yeah, I like to keep it simple and categorize it that we have two gears. We have low gear and high gear. And so low gear is a lower temperature, and you're going to use a lower temperature or low gear when the wood is wetter. If the wood is wetter than 25% moisture content, you're in low gear, lower temperature. And then once you get dry enough, you want to shift it into high gear, and high gear is our higher temperature, which is 160 degrees Fahrenheit. So if you keep it really simple, you can do an awful lot with just that low temperature, 130, higher temperature, 160. There's an awful lot you can do with just that. And then there is the drain cycle thing that you can adjust. We're a closed box. We have all that wood water in the box until we do a drain cycle, and then we dump it. We let it out. But between the drain cycles, we're reusing that wood water to recondition the wood to do conditioning. And so if you want to do more conditioning, you could do longer period between drain cycles. And so some species like to have better or more conditioning, maybe like a walnut, white oak, red oak. Those are always nice to keep conditioned. So you can, and then the pine or cedar, the softwoods, you want to do less conditioning. So you do a drain cycle every 8 or 12 hours. So those are the couple of things you can play with on the drain cycle.
Cool. I'm going to jump into a couple other questions. Jonathan Lyons, curious about the power consumption, cost you can expect. So the iDRY standard is about 3.5 kilowatts an hour. The iDRY Plus is about 4.5, so not a huge difference for doubling the capacity. They're all electric. They're really efficient. The vacuum pump, it's under continuous vacuum, but the vacuum pump only runs about 5 to 10% of the time. So most of the other charges are just your electric fan inside of the unit and your electric heating elements. So 3.5 and 4.5. You can use those as your numbers and calculate your electric cost based off of that. Robert, any thoughts incorporating the top pressure bladder on the standard or plus? They experimented with it in the past. The problem is it's a lot of pressure. You need to be evenly supported. We can do that with our aluminum plates because it's the complete width and length of the charge. When you're on stickers, wherever there isn't a sticker, the wood is going to bend and move on you.
Yeah, we ended up starting to, if you didn't put enough stickers in to support the load, you'd have an imprint where the sticker was in your wood. And then you'd end up having to put so many stickers to support the load. Now you don't have any airflow issues. So that didn't and then we found the ratchet straps with the springs were good enough, and then most guys don't even do that. So
so Pete Clark is talking about torrefying wood. We've talked about it. Jim's talked about it. It's not
we've had that on the engineering papers for 15 years. And that's torrefying is just a scary thing. You're talking about such high temperatures, and so many stories of the torrefying kilns, just imploding and burning down people's factories and buildings, and plus they're expensive and complicated. It's just not something we're ever going to get into. It's
connect
really
you with
complicated. Those are scary. I know it's kind of neat, but that's a scary product.
Cool. So Billy, who's one of our customers, commented he took 45 days for 2.5-inch black walnut, which not terrible. So I guess that's it for questions right now, but let's talk about what do we got coming. So we've got our marketing program that's going to be coming here in a couple weeks, which is exciting. We've been doing some experimenting with how well does a silicone door gasket work in the cold? Greg is asking.
Oh, fantastic.
Man, we had
that thing.
So I said next.
That was a long time coming, that silicone gasket.
Yeah, I would say 90% or more of the calls that we had with issues with these kilns that were running continuously were gasket issues. Is that safe to say? And
Yeah, yeah,
since
yeah, and Jim and I, 15 years ago wanted a silicone gasket. We just couldn't get anybody to make it, to our specifications, and then we just kept forgetting about it. And then every few years we're looking at again, is there a new vendor out there? And so it took a long time to find the right vendor and someone to make that gasket for us. But man, that
and
works well.
not and since it's been out there, which is like, I don't know, 6 months plus, is that right? Right around.
Yeah,
I've
not
had
that
me
long. Yeah,
myself. I have zero calls on the silicone gasket.
yeah,
We've tested it thoroughly. We have a research and development kiln. We pulled a crap load of vacuum. We let it sit there. Our guys in the shop took all kinds of vices and clamps and tried to squeeze it and compress it as much as possible to make it not come back to shape. And then within like a couple minutes, it came right back to shape. So the
yeah,
silicone, the orange silicone gasket is a game changer.
yeah. It's really good.
That is, like I said, our technical support calls and issues have gone from, I would say they're probably 90% less. So
Yeah, and it stays soft in the cold.
yeah,
Your shop can be cool, and it's still the same softness as if it was super warm out.
yeah,
Yeah.
yeah. All right, guys.
Yeah.
Any
So,
engineering questions? Now's your time.
well, and I can just share. Engineering is, like I said, always working on improvements and things, and so we're looking at new machines. First maybe it's the different sizes. We just came out with a really small one for a handful of customers that wanted a really small kiln where they can just put in a pallet size of instrument parts or what have you. And so we released that one, but we're also releasing, I think Paul, you've mentioned it to some customers recently, but the standard size, height and width, but now a longer version of that. So it's what we call the standard extra long. So it's a standard that can do a 16 foot length boards.
Yeah.
So if you don't want to jump all the way up to the plus, so we have now the standard extra long, and that's a new product release in terms of just a different size. And so there's some other sizes that we're looking at too in the turbo series, some super wide, but not, kind of squashed, kind of short but wide for really wide slabs. That's in the developments, and some other things in terms of sizes that we're thinking about. We're always looking for feedback and from our customers. Gee, this would be great if it was, a little bit bigger or a little bit smaller, or if it had this. And a lot of those things we've incorporated over the years, and it's feedback from our customers. So we're constantly trying to make improvements on existing things, but come out with newer products in the future.
And as you talked about, Brian, it's always that balance of bells and whistles are nice, improvements are nice, but we need to toe the line of it. Our motto, it's got to be simple, it's got to be
Yep.
effective, it's got to be
Sure.
easy to service,
Cost effective.
it's got to be
Yeah.
something that's not going to cause more headaches than it's worth down the road.
Right.
So those are some of that's the balance. We don't want to
Yep.
create the Ferrari again. We've done that.
Yeah.
It's really expensive, and some of those things aren't worth doing. So
Yep. Yep.
got Greg Reinbold, good friend of ours and kiln owner, who's thinking about getting a turbo mini. Is there much end checking in the turbo models? From what I've seen, it seems to be pretty minimal, but
Yeah, not really. The turbo models do a really great job of bringing moisture to the surface, in an evenly a nice even way, even though it's fast. And so, yeah, it's pretty minimal. I wouldn't say there's anything that's there's always some logs or a bat, so there's always something that, we're not going to ever prevent end splits or checking. And, sometimes wood is going to do what it wants to do. That drying's not perfect and we're not perfect, but I wouldn't say that
wood's not perfect, right? It's an organic organism.
Right.
There's
it's
stresses, there's knot holes, there's other factors in the wood that we can't control.
So many things. All we can do is dry as evenly and uniformly as possible, and give the wood its best chance.
I got Pete Clark. How does the controller regulate the heating source? Have people connected their kilns to the existing building's hot water system? So are you talking about the plate dryers or the air dryers? Because there's a little bit of a difference there. But
most of our units are electrically heated, but in our turbo series, as we get bigger, we need more BTUs and energy than the electrics can be efficient with. And so with some of the turbos and the water that's circulating in the plates, we've used boilers, and we try to offer a self-contained system. You don't need anything other than here's everything provided. So we've mostly tried to provide the kiln with a boiler, but some customers have opted to use their own boiler or connect to a bigger boiler system in those in some bigger installations. And look, we're just in that kind of system, we're just a zone, right? We're just a room in a house. And we're just a T-stat, thermostat saying I need more heat or I need less heat. So, it's all your same home hydronics, system, whether we're a kiln or it's a room in your house. Hot water heating is pretty simple and basic. Yeah.
Very good. Cool. So give it a couple minutes, see if any other questions come in, but we're almost at the 30-minute mark, which is kind of our goal for these little question and answers. And really liked having you on here, and Brian, help answer some of the questions, chat with the guys, and something we're going to try to do right. And Brian's always available. Like I said, if our team it's a smaller team, but we're very accessible. Brian talks to guys all day, all the time. Same with me. If I don't know the answer, I can either connect you with Brian or get the answer from Brian. We're here to support you guys and help with the technical parts of drying as well as the business side of things. So cool. I guess it's 1:29. We're gonna give it another minute. Get your questions in if you got them.
I guess if anyone out there, we talked about new products and new features. If anybody has a new feature idea, throw it on a chat, but also, like I said before, we're always interested in feedback. There's things you like or dislike. Those are the kind of things we like to hear, and we're constantly trying to be better and make improvements. We will balance that cost and complexity with, sometimes it's a really great idea and it doesn't take much cost and complexity to make a change. We're always about looking into those kind of things.
Awesome. Well, all right, everyone. This is going to be recorded. Jessica, we'll be sure to get it out to anyone if anybody does have any other questions that come up or things that they forgot that we talked about. Paul at iDRYsystems.com, Brian at iDRYsystems.com, or give us a call.
Yeah.
Okay.
Stay in touch, everybody. Thanks.
Thank you, Brian. Thanks, everyone.
Thanks, Paul. Thanks, everybody.
Have a great day.